Okay, our next unit is on transformations. We're going to be going back and revisiting three ideas that we talked about before when we were studying congruence. The transformations we've already dealt with are reflections, translations, and rotations, and so those are the three we're going to go back and revisit in a little bit more detail. We're starting with reflections. If you look at the targets, we're going to identify reflections, and we've done a little bit with that in that congruence chapter. What's new is we're going to draw reflections, and then we're going to apply these principles of reflections to solve problems, and then we're also going to talk about what it means to reflect if you're in the coordinate plane. And so you're going to see some commonalities here. We're going to have the same kinds of targets when we work with translations, and then also rotation. So we'll be identifying, drawing, applying, and then using them in the coordinate plane. All right, so let's review what a transformation is. We talked about these before. A transformation is a change in the position, size, or shape of a figure, or you could say of a graph. Okay, and so a reflection is one type of transformation. Specifically, a reflection is what we call an isometry. An isometry is a transformation that does not change the size or shape of a figure or graph. Okay, so a reflection fits into that category. It does not change the size of the figure, nor does it change the shape of the figure. We're going to call a reflection to start here. We'll get a little bit more detailed definition in a minute, but we're going to start with a reflection is a transformation across a line that creates a mirrored image. All right, so for example, if this is my line right here and I had a triangle like this, the mirrored image might be something like that. Okay? Perfect, but you get the idea. I'm mirroring it across this line. All right, so if you look below on identifying reflections, we did a little bit of this in the previous chapter. Tell whether each transformation appears to be a reflection. So you should be looking to see whether you could draw that line of reflection in and picture the mirrored image. So I hope this first one's pretty easy, right? If I put a line in there, you should see that these are mirrored images of each other. If you go to try to put the line in, I'm going to put yes here. If you go to try to put a line in here, okay, that is not a mirrored image, right? This is actually a translation. It's a slide, but a mirrored image, right, would take this and reflect it over and make it more of this shape, and then would take this shape and mirror it over and make that kind of a shape. So you can see that's not what we have here. So that is a no, it's not a mirrored reflection, it's just kind of a slide. All right, so now try these two up here. Let me give you a minute. Look at those stars. Does that appear to be a reflection? Hopefully you can see no. I don't think there's any way to put a line in there that would cause a reflection. But if you examine this one closely, right, and you picture a line drawn right through here, where this might be the mirrored image here of its partner. So this one would be yes. Okay, so you should be able to see that reflection over a line. So now I'm going to show you how we can actually draw one without too much work here. We're going to use paper and what we call patty paper, which is this kind of little thin sheet of paper. And if you look at your instructions on the paper there, it says draw a triangle and a line of reflection on the piece of paper. So I'll do that for you. I'm just going to draw some kind of a triangle here, and I'm going to need to use a different kind of a marker. Let's try that again. Patty paper is kind of like tracing paper. So if I draw a triangle, and then I'm going to draw a line of reflection, I'm going to draw it kind of like this. Okay. And then it says, fold the patty paper back along the line of reflection. So if you had any kind of tracing paper, we're going to take it and we're going to fold it on that line of reflection. Make a nice fold. And then because it's tracing paper, if I flip it now, I can see the triangle through. So you notice the next step is to trace the triangle through. So now if I press down and I use my ruler, I can see the triangle I have there. I'm going to trace it. And make sure you have your rulers handy because we are going to be drawing. Alright, so now I've traced it, and now look, if I unfold, I've created a mirrored image. So I've created a reflection. So it's really handy if you have this kind of patty paper and this tracing paper. Alright, so if you read below those numbers on your sheet, it says draw a segment from each vertex of the pre-image, or the first one, to the corresponding vertex of the second one. Alright, so let me do that for you. So let's say we connect this vertex of the first one with the vertex of the second one. I can do that here. Here are corresponding vertices. I'm going to connect those. Again, make sure you're using a ruler. Okay. So now my red lines are the ones I've connected. And it says, what do you observe about the relationship between the segments and the line of reflection? Now this is my line of reflection right here, my reflection line. So look at that closely, and what do you see about the red lines? And maybe if I turn it, I'll give you a hint. What do you see in the relationship between the red lines and this line of reflection? You should notice two things. One, this line appears to bisect all these red segments. So those two look congruent, these two parts look congruent, and those two parts look congruent. So that's one thing. It seems to bisect the segments. The other thing I'm hoping you notice is that it looks like we have perpendicular right here. All right. So in fact, this line of reflection is the perpendicular bisector of all these red segments that I've drawn. So remember, the red segments were connecting the matching vertices, and so that line of reflection is the perpendicular bisector of those segments. So that's where the geometry really figures in here. All right, let's write that up on your notes sheet. So in that box right here where we left off, it says a reflection is a transformation across a line called the line of reflection, so that the line of reflection is the perpendicular bisector of each segment joining each point and its image. So if I connect the point and its image, that line of reflection should be perpendicular to it and bisect it. And we're going to use that information now to help us draw, without the patty paper, an actual reflection. So get your rulers ready here. Draw the reflection of the quadrilateral across the line. So step one is going to be to draw a perpendicular line to the reflection line from each vertex. So let's start with that. I'm going to actually label these A, B, C, and D. All right, so I'm not going to ask you to use a protractor. I'm going to allow you to kind of eyeball the perpendicular part. So for example, from A, I'm going to kind of use this guide on the ruler here. I'm going to line that up on my line, and I'm going to construct perpendiculars. And now I'm going to do one through B. Right, I'm trying to use one of these lines as a guide for perpendicular, and now I have to line it up with B. And then I'm going to do it with D here. And obviously there's going to be some error involved because we are sort of approximating the perpendicular. All right, so that's step one. All right, I drew the perpendicular lines to it. All right. By the way, what do you notice about all of these red lines? If they're all perpendicular to that reflection line, doesn't it mean that they are parallel? Okay, so keep that in mind. The second step would be to measure the distance from each vertex to the line of reflection, and then measure out the same distance in the opposite direction. So we're creating that bisector piece. So let me get another color. We'll call this step 2 here. All right, so for example on A, I'm going to use centimeters. It's a little easier to measure. I'm going to measure from A, on my red line, from A to the line of reflection. Looks like about, 1.7. So now if I go to the line of reflection and I measure out another 1.7, that would put me right here. So I'm creating that congruence piece. Okay, so now I'm going to do it for B. I'm going to measure on my red line, B to the line. It looks like exactly a centimeter. So if I measure a centimeter out, all right, this could be A prime, this would be B prime. I've preserved that congruence piece, the bisector piece. Now I'm going to do D. D looks to be about 3.2. Okay, if I measure out about 3.2, that would be my new D. And if I measure for C, I think I'm once again at about 1.7. Okay. And you should be able to kind of see just by eyeballing it whether you've measured pretty close. And you're going to definitely know your last step is then just to connect. So if I connect my new vertices in blue here, I have my mirrored image. So step 3, connect the new points. And that's what I did in blue. Okay. So again, to review, right? First thing we did was to draw the perpendicular lines from each vertex. Those were the red lines. Just made them long enough to cover what I needed. Then in step 2, I measured from each vertex on that red line, how far is it to the line of reflection. If I need to have a bisector, then I have to measure that same distance out over here. And so I did that for B, for D, and for C, and then with those new points I connect and I should have a mirrored image. Okay? All right. I'm going to leave this you try example so that if you want to mess with another one on your own, you can do that. We're going to jump down here to example 3, which is problem solving. This was our third target. This is kind of shortest path type of problems, we're going to call them. It says a trail designer is planning 2 trails that connect campsites A and B to a point on the river. So we're going to call this line the river. He wants the total length of the trails to be as short as possible. Where should the trail meet the river? So the question is, should he go here and then to B? Should he go here and then over to B? So where is it exactly that he should walk to on the river and then go to point B to make the shortest path? So that's what these problems are all going to involve, kind of looking for that shortest path. So there's a real easy strategy. All you really need to do is to reflect one of these points over the line. So you can choose A or B. I'm going to use B. So just like we did a minute ago, right? To reflect a point, you're going to go from that point perpendicular to the line. So I'm going to use my ruler and I'm going to eyeball perpendicular using some lines on the ruler. All right, I think I'm pretty close. I'm going to construct that perpendicular line. That's just like we did a minute ago. That was step one. And then we also need a bisector, so now I have to measure the distances if I'm reflecting that point. So just like we did in the last problem, I'm going to measure from from B here to the line that looks to be just over 1.5 centimeters. So now I'm going to measure out 1 centimeter, just over 1.5 centimeters. That would be B prime. So I reflect the point. So I'm going to say reflect one of the points. And then connect that point to the other point. So in our case, that's going to be A. So I'm going to connect B prime to A. And where it crosses the river, right here, that's my shortest path point. So where that segment crosses the reflection line is the shortest path point. So if I wanted to build the shortest path, I would go from A to this point and then from that point back to B, and that would be my shortest path. So you can see it has a variety of applications. If you look at the one below, we can do this one quickly. Two buildings are located at A and B and are to be connected to the same point on the water line. So this time my reflection line represents the water line. Where should they connect so that the least amount of pipe will be used? So least amount of pipe will be used. Once again, that's this idea of finding a shortest path. So looking at your steps above, the first thing we want to do is reflect one of those points. Doesn't matter which one you do. I'm going to take A and reflect it, so I need to create a perpendicular line through A to my reflection line. That's step one, right? Perpendicular bisector, so now I have to measure the distances to create the bisector. So if I measure this distance, it looks like about 2.6. So if I measure out 2.6 centimeters, there is my A prime. All right, that was step one. Connect that point to the other point. Well, my other point was B. So I'm going to connect that to B. Where that segment crosses the line of reflection, that's my shortest path point. So here it is right here. That's the shortest path point that I want. So I would want to go from A to that point to B. That would be my shortest path. Okay? All right, our last one, target, just deals with the coordinates. So that's on this last page. We're going to look at a couple of examples and try to develop some rules. So it says reflect the point 2, 5 across the y-axis. So here's 2, 5. And if I reflect it across the y-axis, right, I should go 2 into the axis and 2 boxes out from the axis. I would be right here. So that new point is -2, 5. So then I'd ask you, can you come up with a general rule? If I put that same point down here, if this is x, y, what would this point be called over here? Right? What changed? The 5 didn't change, so this point would still have y as a coordinate, but the x went from 2 to -2. So x would go from x to -x. So my rule is xy becomes -xy if I reflect it over the, oops, this should have been y-axis. I went the wrong way. Sorry, you guys. I just caught that. This should be y-axis. We'll flip it around and we'll do x-axis over here. My bad. So this is y-axis. Sorry about that. All right, so now let's do the same thing now that I've messed you up. Here's 2, 5. And now let's go across the x-axis. Right? So if I'm reflecting, I would count 5 boxes to the line, so I'd have to count 5 boxes out from the line. I'd be here. Well, what are the coordinates of that point? 2, -5. So look at what happened when I went across the x-axis. The 2 did not change at all, but the 5 went from 5 to -5. So if we have a point, and we're going across the x-axis, if I generically call it xy, when I reflect it across the x-axis, the x stays the same and the y changes. So xy becomes x -y. So notice the y-axis meant the y stayed the same. And when we reflected across the x-axis, the x stayed the same. And it's the other variable that changes sign. Now this one's kind of interesting. We're going to reflect across the line y equals x, which is that line right there. So if I pick the point 2, 5 again, which is here, and I reflect across that line, I'm going to go diagonal a box and then diagonal another half a box. So then I'd have to come out half a diagonal and another diagonal. I'd be right here. That coordinate is 5, 2. So do you see the relationship there? What happened to 2, 5 and 5, 2 when I went along this line y equals x? Hopefully you can see xy just got turned around and was now called yx if we reflect over that line. So if it's going over the line y equal x, we just change those positions. These are some really great rules to have because you don't want to have to graph it every time you do it. So here, if we're reflecting across the x-axis, peek up above, x-axis means the x stays the same and the y changes sign. So now that I know that, my new points, x prime, x stays the same, y changes sign. Y prime, the x coordinate stays the same, the y changes sign. And z prime, the x stays the same, the y changes sign. Whoops, what am I doing here? Changes sign, I'm putting it in the wrong spot. Okay, so it's really simple if you know those rules. So here, if I'm going across the line y equals x, look up at your rules. That just means I switch the positions. So d prime would be 0, 2. E prime, well, it's still going to be 2, 2. It doesn't change because that's actually sitting right on the line y equals x. F prime, if I switch them, would be 2, 5. And G prime would be 1, 5. I'm not changing any signs. I'm just switching positions. All right, that's it for today.